This question says, use the vertical line test to determine whether the graph represents a function. So we're given this picture of a graph. That graph will be a relation, but we want to know if that graph is a function. So we use the vertical line test to determine this. In the vertical line test, we're drawing vertical lines all over the graph. And as we draw the vertical lines, we're counting how many times that vertical line crosses the graph. So for this vertical line, we have one time where the vertical line crosses the graph. Here, one time. On this one, it crosses in 3 places. Here it crosses in 3 places. Here it crosses in 1 place. And here it crosses in 1 place. And what we want for something to be a function, we want to have exactly 1 y value. That's the definition of a function, that every x has exactly 1 y. So when we have these situations where the vertical line will cross the graph in more than 1, so we'll say 1 because we're looking for exactly 1. So we have these places where the vertical line crosses the graph in more than 1 place. These are places where the graph is violating the definition of a function, where you have 1 x value with more than 1 y value. So since we have a couple places where vertical lines cross in more than 1 place, this is not a function. This question says, use the graph of y equals f of x to answer the following question. What is the y-intercept of f? A y-intercept is where the graph crosses or touches the y-axis. We have our y-axis here, which is the vertical axis, and we can see right here is the point where the graph crosses the y-axis. So this graph has a y-intercept of 0, -5. This question says, find the x-intercepts and y-intercept of the function. I like to find the y-intercepts first. They're usually a little bit easier. So to find a y-intercept, we're going to let x equal 0. So essentially we're calculating f of 0. So everywhere I see an x, I'll change it to a 0. That's 3 times 0 minus 21. 3 times 0 is 0, and 0 minus 21 is -21. So the y-intercept for this function is the ordered pair 0, -21. Then we want to find the x-intercept. To find the x-intercept, you let y equal 0. And in our function notation, f of x is what represents y. So we're letting f of x equal 0. That would give us 0 equals 3x minus 21. And we'll solve that equation by adding 21 to both sides. That gives me 21 equals 3x. I'm going to solve for x by dividing by 3. That gives me x equals 7. And my x-intercept is the ordered pair 7, 0. This question says, find the x-intercepts and the y-intercept of the function. And our function is f of x equals 9x squared minus 4x minus 2. I'll find the y-intercept first. To find the y-intercept, you're going to let x equal 0. So we're substituting a 0 into our function. That would give me 9 times 0 squared minus 4 times 0 minus 2. 0 squared is 0. 4 times 0 is 0. 9 times 0 is 0. Negative or minus 0 and minus 2 combine together to be minus 2, and 0 minus 2 is minus 2. We have a y-intercept at 0, negative 2. Then we'll find our x-intercept. To find an x-intercept, you let y equal 0. And the y in this example is f of x, capital F of x. That is our function notation. So we're going to let capital F of x be 0, and that would give me 0 equals 9x squared minus 4x minus 2. And I might try to factor this first. The numbers that go in this position and this position would need to multiply to be 9x squared. So I have some choices for factors of 9. That's 1 times 9 and 3 times 3. So I'd probably try 3x and 3x first. The numbers that go in this position and this position need to multiply to be negative 2. I only have one choice for factors of 2. That's 2 times 1. I would do 2 and a 1, and I would test out the inside and the outside because I want to make sure that I would get the right middle term. So for the inside and the outside, that would be a 6x and a 3x. And if I combined 6x and 3x by either adding or subtracting, that's not going to create a middle term of 4. So I know this is not the right choice. Normally, I would say we would switch the 2 and the 1, their position. But since our beginning numbers are the same, switching the 2 and the 1 aren't going to give me a different combination. So I need to switch my front numbers and try 9 and 1. So I'll try a 9x and an x. Once again, testing the inside and the outside. That would be 2x and 9x. If I add and subtract 2x and 9x, that's not going to create the middle number of 4x that I need. So let's try switching the position of the 2 and the 1. And for my inside and outside, that would give me x and 18x, and once again, that's not giving me the middle term of 4x. So I've tried every combination of factoring and it doesn't work. So I'm going to rely on, instead of factoring as the method to solve this quadratic, I'm going to try the quadratic formula. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A, B, and C are referring to the coefficients in my equation. So for this example, and every example, A will be the coefficient of your x squared term. So that's 9 for this example. B is attached to your linear term, which for this example is negative 4. And C is the constant, which is negative 2. I'll substitute these values into the quadratic formula, which will give me negative b plus or minus the square root of negative b squared minus 4 times a, which is 9, times c, which is negative 2, all divided by 2 times a, which is 9. Then I'll begin to simplify this using order of operations. So negative is positive. Negative 4 squared is a positive 16. And then I have 4 times 2, which is 8, times 9, that's 72, all over 18. Underneath the radical, I'm going to add 16 and 72, which would give me 88. And then I want to try to simplify that radical. And when I simplify the radical, I'm looking for perfect squares. So I'm looking at factors of 88. That's 1 times 88, 2 times 44, 4 times 22, 8 times 11. So we want to choose this factorization because 4 is a perfect square. 4 is 2 squared. That's going to allow me to simplify the radical. So that's 4 times 22 underneath the radical. And we're able to do the square root of 4 times the square root of 22. So we've applied that radical to each factor. The square root of 4 is 2. And 22 is not a perfect square, so I'm not able to simplify that anymore. And the last thing that I can do here is anytime you have fractions, you want to try to reduce them, write them in lowest terms. You don't want any factors in common between the numerator and denominator. And as I look at this numerator, I can see that these two terms are even and this term is even. So that means that they'll have a common factor of 2. I'll cancel out that factor of 2 from 4 and from 2 and from 18. And that's going to leave me with 2 plus or minus 1 square root of 22 over 9. And 1 square root of 22, that's 1 times square root of 22. And 1 times anything is itself, so we can get rid of that 1 there. So we found the x-intercepts to be 2 plus square root of 22 over 9 and 2 minus square root of 22 over 9. I'm going to kind of zoom out so you can see all of the work at once. In this question, we want to find x-intercepts and y-intercepts of the function. I like to start with y-intercepts because they're always a little bit easier. And when you're finding a y-intercept is where the graph either crosses or touches the y-axis. And because it's on the y-axis, that means that the x-coordinate will be 0. So the way that we find y-intercepts is by letting x be 0. So I want to substitute a 0 into the function, and that's going to give me, 0 cubed minus 0 squared minus 7 times 0 plus 7 over 0 squared plus 10. So I substitute a 0 in for x, and I'm going to simplify. And 0 cubed is 0, 0 squared is 0, 7 times 0 is 0, and 0 squared is 0. So we end up having 7 over 10 when we add all those up. So we have a y-intercept of 0 and 7/10. So then I want to find the x-intercept. Like I said, this is usually a little bit harder. An x-intercept is where the graph either crosses or touches the x-axis. And because it crosses or touches the x-axis, the y-coordinate will be 0. Our equation here is written in function notation, and it is f of x equals x cubed minus x squared minus 7x plus 7 over x squared plus 10. And because it's in function notation, this f of x is representing y. So we're going to be setting f of x equals 0. And that would give us the equation 0 equals x cubed minus x squared minus 7x plus 7 over x squared plus 10. And we want to solve this equation. When we first look at it, it looks pretty messy because of the fraction. There's a method for getting rid of the fractions called clearing fractions. And what we do is we multiply by the denominator on the left and the right of the equation. Whatever you do to one side, you have to also do to the other. And that is going to cancel out the denominator on one side. And on the other side, because we have a 0, 0 times x squared plus 10 is 0. So the fraction goes away and we have 0 equals x cubed minus x squared minus 7x plus 7. And we have this polynomial equation that we're going to solve. So the technique that I'm going to use to solve this equation is called grouping. I'm going to use factoring and grouping. So I'm going to group these two terms together and group these two terms together. And we're going to factor out the greatest common factor from each group. The greatest common factor of x cubed minus x squared is x squared. If I factor that out, I'm left with x minus 1. And for the other group, I want to factor out the greatest common factor. We've got negative 7x plus 7. They have a common factor of 7. And I also want to include this negative sign. I want to carry that down, make this a minus 7 for what we factor out. If I factor out that negative 7, I'm going to be left with x minus 1. And if this grouping method is going to work properly, you need what's in these parentheses to match each other. And if they match each other, you can now consider that to be the greatest common factor of this term and this term. You now have two terms, and they have this common x minus 1. I'm going to factor that common factor out. And what's left is this coefficient and this coefficient. So we have x squared minus 7. So now I have it factored. It's 0 equals x minus 1 times x squared minus 7. And you set each factor equal to 0. And on this factor, x minus 1 equals 0, we would add 1 to both sides and get x equals 1. In this other one, we have x squared minus 7. I would add 7 to both sides. That gives me x squared equals 7. And I'll continue solving by square rooting both sides. And when you square root a square, they cancel each other out and you get plus and minus on the other side. And so we have positive square root of 7 and negative square root of 7. So we have x equals 1 square root of 7, negative square root of 7 as our x-intercepts. If we write those in as ordered pairs, that would be 1 comma 0, square root of 7 comma 0, and negative square root of 7 comma 0. Those are our x-intercepts. Thank you for checking out my videos. Have a great day.